Good morning, everyone. We are almost done with new material for AP Calculus AB. So close I can taste it. We have today's lesson will be the last big lesson, and then we have one more small topic. So I usually try to be done with the curriculum by spring break, and it looks like we made it. Okay, so what you're going to need for this second to last topic is this L'Hopital rule packet, which I gave you on the last day that I got to see your smiling faces. If you were absent on that Friday, this is saved as a PDF in modules. So go ahead and pause, access it, and join back up. I'm going to split this video into two videos. The first video is going to be on just a general limit review so that if you feel solid with limits, you don't necessarily have to watch every single minute of this first video. And then the second video will be on the new topic, which is L'Hopital's rule. Oh my gosh. Okay. So you can see it's been like 4 weeks. Woo. Okay. All right, my friends. So limit strategies. We learned this when we first met in August. It was the very first thing we started with. So we went ahead and some problems we had to graph. Some problems we did some algebra. And by algebra, I specifically mean factoring. Some problems we thought about end behavior. So we asked ourselves whether or not there was a horizontal asymptote, for example. There were a couple of limits that you just had memorized. And there were some cases where we just had to kind of figure it out. We called it using logic. So here are some strategies. And so now I'm going to go to the L'Hopital rule packet. And in this first video, I'm going to just as quickly as I can, go through limits because it's been many, many, many months. So I might just skip around a little bit. Especially because these first three are all the same method. So if you look at a problem and there's absolutely no reason that you couldn't just pop that value in, then you use substitution method. So this is substitution, substitution, substitution. And so, for example, if I plug this 1 in, I get -2 plus 12 minus 17. So -2 plus 12 is 10. 10 minus 17 is -7. So the way that we read this is when the x's are getting really, really, really close to 1 coming in from both sides, the y's are getting closer and closer and closer to -7. If substitution method works, I would like you to remember that when substitution works, the function actually assumes the value. There is no hole, there is no jump, there is no asymptote. When the x's were getting close to 1, the y's are trending towards and actually equal that -7. For this problem, you would also just pop the 2 in. And for this problem, you would just pop the pi over 3 in. So I'm going to pause and do that so that this video isn't too lengthy. Okay, we're back. So moving on to number 4, and you can go ahead and check these if you did them. Moving on to number 4, I can't plug a 2 in because you can't have a 0 in the denominator. But also if there was a little minus superscript in the subscript, like a little tiny minus or a little tiny plus, then that meant coming in for this problem specifically from the left. So whenever I was only asked to look in one direction, graphing was always my strategy. So this is a rational function. It has a vertical asymptote at 2. It has a horizontal asymptote actually at 1. I don't think that's going to affect our answer for this one. And then if you did some pre-calculus test points, it would look something like this. So when I'm coming in towards 2 from the left-hand side, what are my y's doing? When I'm coming in towards 2 from the left-hand side, what are my y's doing? They are gravitating towards -infinity. Okay, 5 and 6 are the same strategy. I can't plug a 3 in because I would get 0 in the bottom, I think. 9 minus 6, yeah. And I can't plug a 2 in for probably the same reason. So for 5 and 6, you're going to just go back to your algebra skills. So you're going to go ahead and factor. And then you won't be taking a multiple choice AP if you signed up for it this year. But if this did make an appearance in like part A of one of the free response questions, limits have traditionally been in multiple choice land, you would have to write the equivalent limit. So when you do some algebra, make sure you rewrite the problem that you are doing, and this answer would be 1/4. I'm going to go ahead and pause it and bust this one out. Okay. Go ahead and check, see how you did. And then the final row, when it said infinity, you're thinking about when x is really, really, really big. Or if it says negative infinity, when x is really, really, really small. So for these problems, you want to consider end behavior. Considering end behavior means, does the function have an asymptote? Because if the function has an asymptote, it's going to gravitate towards that asymptote. For number 7, there is no horizontal asymptote. And I know that because the degree is bigger on the top than the bottom. If a function isn't leveling out at an asymptote, I hope that these words sound familiar and you remember me saying it, because I feel like I said this a lot. If it doesn't level out at an asymptote, it either goes up or goes down. And it's your job to figure out which one of those is happening. So for number 7, if I plugged an infinity in, I would get an infinity out. You're just thinking about positives and negatives. For number 8, there is an asymptote. The degree is the same on the top and the bottom, the exponent. And when that happened, you looked at the coefficients. So 3/9 is 1/3. There is a horizontal asymptote at 1/3. So at the very end of the function, when the x's are getting really, really big, those y's are getting closer and closer and closer to the horizontal asymptote. And then if the degree was bigger on the bottom than the top, your horizontal asymptote was at 0. So we went ahead and we did substitution in the first row. In the second row, you had a little bit of review with graphing and then algebra. And then all of the problems in this last row are end behavior. Okay, almost done with August, September limit review. There were some we should just recognize. So this is one that we went ahead and memorized. I had you guys look in your graphing calculator, and this is what the picture looked like. And we said, all right, when x is getting closer and closer to 0, coming in from both sides, the y's are trending towards 1. This is a worksheet that Mr. Bennett and I both use in AB and BC. AB did not memorize this one. We do not recognize this one. So I would ask you to maybe pause and type it into your calculator and just steal the answer from your graphing calculator. It's not going to matter that we didn't take the time to memorize this, because with today's trick, we'll be able to do this nonetheless. I'll come back to this. I'm almost done with review. For number 12, this looks hideous. This looks terrible, but this is H. And so this is actually the formal definition of a derivative. Reminder from so long ago, when we first learned how to do a derivative, we traveled H to the right. And we had a secant line. And we shrunk H. We let H get closer and closer and closer to 0, so that that secant line morphed into our tangent line, which is our slope at a point, which is our derivative. All you have to do if you ever see something like this is recognize that this is the derivative. The derivative specifically on tan at pi over 4. Because this is the function, and this is in lieu of that a. F of a plus h minus f of a. So if I want to find the derivative on tan at pi over 4, I would never actually do the problem with limits. I would go, okay, well, I know the derivative of tan, my slope spitter outer is secant squared. And then I would just plug pi over 4 into my slope spitter outer. So if I plug pi over 4 in, what do I get out? Oh goodness, secant of pi over 4 is the flip-flop of cosine of pi over 4. So instead of root 2 over 2, it's 2 over root 2, which of course I'm then squaring. So I think for this problem, I would put 4 over 2, which is 2. Really miss your guys' nods and eyeballs that are giving me those positive affirmations as I do these problems in class. Okay, back to this one. I'm going to pause and type it into my graphing calculator as well, and then writing in this answer will be our last piece of video 1. Okay, I typed the function into Desmos, and I looked at what was happening around the picture when the x's were getting closer and closer and closer to 0. I'm in webcam only mode right now, or I would toggle onto my screen, so hopefully you have a graphing calculator at home. When I looked at my picture, it looks like those y's are gravitating and actually, no, they're not equaling. They're gravitating towards 0. Okay, so this concludes the review video. We're going to go to video 2 now, where we actually learn how to do a final limit strategy. And if you are wondering why the heck didn't we learn this limit strategy in August and September, it's because you need things that you've learned since then to do this final limit strategy.